Good morning, everybody. Looking at another screencast video tutorial. Today is, I'm not even sure what today is, maybe February 17th, 2014. Anyway, this is an SAT type question. May have actually appeared 6 or 7 years ago. This was a grid-in question. Absolute value of x minus 3 greater than 6, less than 7. If x is less than 0, what is one possible value for absolute x? Grid-in meaning the student has to generate his or her own answer. We'll look at several approaches here, and I'm also thinking about this not just from a student point of view, but from an educator point of view. As math teachers, how do we implement Common Core to develop conceptual understanding, have students make connections, use a variety of strategies, and deepen their understanding of mathematics? I think it's helpful to know that no matter what methods we may teach, when students take standardized tests, based on my experience, they all like to plug in. A few will think of standard procedures that were taught in school, but many of the test-wise students, I shouldn't have said all, but many, will think about what values of x will make this inequality at the top true. And they might try x equals 9, and the absolute value of x minus 3 in this case would equal 6, but we want it to be greater than 6. We might try 10, and 10 minus 3 in absolute value equals 7. Again, not less than 7. If they're thinking clearly about the inequality, they might now try 9.5, and that would seem to work. Even your strong students, when faced with a problem like this under timed conditions, under testing conditions, will tend to ignore key pieces of information or read too quickly and simply miss it or forget it. And certainly this fact, or this given, was critical. Students should therefore learn to circle, underline, highlight, do whatever it takes to make sure they don't miss critical pieces of the problem. X less than 0, so 9.5 would appear to work, but it doesn't. Well, we could go on and talk about plugging in negative numbers here, but rather than that, let's move on to what has traditionally been considered the modus operandum of most of us in the classroom as math instructors, and that is a procedural approach. If the absolute value of this quantity is between 6 and 7, then it means this quantity is greater than 6, less than 7, or between negative 7 and negative 6. Since we're interested in negative values of x, we'll focus on this part of the disjunction. Solve for x, and we see x is between negative 4 and negative 3. We added 3 to all members of that inequality, so a reasonable value to pick for x would be negative 3.5 or any other decimal, and we can then grid it. But no, we can't, because you cannot grid negative numbers, and that's why the problem asks for a possible value for absolute x. So the absolute value of x would be 3.5, and that's what you would grid if you were taking a standardized test like the SAT. 3.5. Let's move on to other strategies and instructional modes, and this is kind of related to multiple representations, the rule of 4, developing conceptual thinking. For absolute value, I think it's very powerful to use the distance model on a number line. So absolute value of x minus 3 is, or can be thought of as, the distance between x and 3. This is becoming more commonplace in our curriculum and textbooks, but I still think we could emphasize it even more. So from the original inequality, we want the distance between x and 3 to be between 6 and 7. So that would be a verbal interpretation, or on a number line, for the given problem. Drawing a number line, locating 3, and moving a distance of 6 or 7 to the right, we would be at 9, or we'd be at 10. So if it's between 6 and 7 units from 3, we would want values of x between 9 and 10. But absolute values have a symmetry to them, just as distance does. So we could move to the left 6 or 7 units, and if we move 7 units to the left of 3, we would be at negative 4. 6 units, we would be at negative 3. So this suggests the other part of our solution, values of x between negative 4 and negative 3. So the distance model is powerful for students to be able to visualize solutions without the standard algebraic procedures. Moving on to a graphical interpretation, which we all know is very powerful for Algebra 2 students and above. The original inequality can be interpreted in terms of 3 different functions. We could call this y1, absolute x minus 3, y2, y3, and remember the original inequality kind of it can be now interpreted as y1 is greater than y2, less than y3, which means we can think of it graphically as determining points on the absolute value graph which are between the 2 horizontal lines, y equals 6 and y equals 7. And those and that region would be in here, and the values of x we want are between 9 and 10, which we could do on a graphing calculator or see it visually here. And again, by the symmetry of the absolute value function, we see that there are other points on the graph which are between the horizontal lines y equals 6 and y equals 7, and they would correspond to the negative solutions for x between negative 4 and negative 3, and negative 3.5 then would be a suggested value, and we can complete the problem that way. So here we have a standardized test question which can lead to a variety of instructional modes, making connections, graphical interpretation, number line distance interpretation using verbal mode. Our standard procedures, and I'm not denigrating this method, it is important and it is necessary for the more sophisticated absolute value problems. The student preferred, and we can't ignore it because they're going to do it, plugging in, but they have to be so careful about reading instructions. Thank you.